x over h. We're asking about, I'm going to ask about two things. What about, I'm going to call this the derivative with respect to x of f of x. What about the derivative with respect to x of f of x minus g of x? The derivative with respect to x of f of x over g of x. That's the question. Two different questions. Okay? And we're going to give the answers right now, and then we're going to go through the derivation of both answers. Okay? So I'm going to furthermore call this f prime of x. And the derivative with respect to x of g of x, we're going to call g prime of x. It's not just me calling that. Even here is common notation for derivative. So who remembers what this becomes?
X minus g prime of x.
F prime of x minus g prime of x. We're going to prove that in a second. And Trey, do you remember what this one becomes?
Low-D high minus high-D low over low-low.
Low-D high minus high-D low over low-low. Low yodeling is good for everyone. So that translates into what in terms of
G of x times f prime of x minus f of x times g prime of x over g of x.
Not a good marker. Okay? So here we go. We're gonna do the proof of this. So proof. Get some marker that's dark. The derivative with respect to x of f of x minus g of x is f prime of x minus g prime of x. Okay? We're given the derivative with respect to x of f of x is f prime of x, and the derivative with respect to x of g of x is g prime of x. Now notice, this isn't trivial, because even though some people love this and say, what's the big deal? It's like you're distributing the derivative, and you get f prime of x minus g prime of x. But here we do not get f prime of x over g prime of x. It doesn't work. So it's not trivial. So it's not unreasonable to look at both of them. So we do it this way. Here's the proof. By definition, the derivative with respect to x of f of x minus g of x. Now I'm going to do this one myself. Now I'm going to get a lot of input on the bottom one. So see if you're catching on. Like I say, you're bored, ponder the extensions. Think about what's going to happen when we go there. All right? Is the limit, and there's other ways to define it, but the limit is h goes to 0 of, and I got to do a little thing in here. I'm gonna just make a note that I'll go with capital K of x is f of x minus g of x. So once I've done that, this is the same as the derivative with respect to x of k of x, which is the limit is h goes to 0 of k of x plus h minus k of x over h. Agreed? Which is, well, k, this is saying that k of something is f of that thing minus g of the thing. We always use x's. But the x is k plus x. The delta is k plus x. F of triangle, k of triangle is f of triangle minus g of triangle. So k of x plus h is f of x plus h plus, minus g, make that a minus, of x plus h. Okay? And then I subtract from that k of x, which is clearly f of x minus g of x, which can be rearranged into the limit is h goes to 0 of f of x plus h minus f of x over h plus, make that a minus g of x plus h minus g of x over h, big brackets. Are you okay with the negative signs? Notice I have minus g of x, just like I did there. Notice I have minus f of x in both spots. I have minus g of x in both spots. I have positive f. I meant to say minus g of x plus h in both spots. It's pretty trivial, right? You guys are bored. This is too easy. The limit of a plus b, because it's also something that I'm not proving now, but the limit of a plus b is the limit of a plus the limit of b, as long as you keep what you're looking for the same in both cases. So this ends up being the limit is h goes to 0 of f of x plus h minus f of x over h, minus the limit is h goes to 0 of the g business, which is by definition f prime of x minus g prime of x. Done. Okay, I'm going to take volunteers. We're going to do the next one. Try to speak real loudly so that it'll pick up, because the audio is not as good as I thought it was. First volunteer to start this proof. Do I need to go to the random number generator? All right. Tell me what to write right on top. I want it to be totally analogous to this as possible.
Prove d dx of f of x over g of x is equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared.
Okay?
And we're given that d dx of f of x equals f prime of x and d dx of g of x equals g prime of x.
And put this in there, make that a given too.
Okay, and let k of x equal f of x over g of x.
Awesome. Now, speak up at any point you're disagreeing with the line of reasoning. Go.
The limit is, well, derivative with respect to x of k of x is equal to the limit as h approaches 0 of k of x plus h minus k of x all over h, which equals the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x all over h. That equals the limit as h approaches 0 of f of x plus h over, or f of x plus h.
What are you doing? What's your approach? What are you doing? Suggestion?
Multiply f of x plus h times g of x top and bottom, and
Common denominator.
and g of x plus
Now, this isn't the only way to do it. So, Nick, we interrupted you because I felt you pausing a little bit, and we went with an approach that I know is going to work. Your approach might have worked too, okay? So we're just going to write that as f of x plus h g of x minus f of x g of x plus h all over g of x plus h and h. And if we take the limit of this as h goes to 0, when h goes to 0, the top is f of x g of x minus f of x g of x is 0. The bottom is, who knows what that is, g of x squared, but times 0, 0 over 0, which we expect. It's a slope. As you get the x to 0, the y is going to 0. So when it's 0 over 0, we need to do some tricks. But we can't use L'Hopital's rule because that's circular reasoning. We're deriving the derivative. We're way back, way back. Okay, so this equals, I'm going to write it again one more time. The limit is h goes to 0 of, stretching it out a little bit, I have my reasons, g of x plus h, on top I have f of x plus h, g of x, minus f of x, g of x plus h. Any of you, I did it for you two guys last year. I did it in class for you guys, but probably with the products rule, not the quotient rule. Does anyone know what I need to put in there? Okay, we're stuck. So we come to the bottom. Equals the limit as h goes to 0. Think about what we're going to end up with. If this is going to be right, we're going to end up with, really, we're going to end up with g of x times the limit is h goes to 0 of f of x plus h minus f of x over h minus f of x times the limit is h goes to 0 of g of x plus h minus g of x all over h, all over g of x, the quantity squared. That's correct. I got to fill in the gaps. I left some gaps in here. What do you think I'm getting at? What are we going to do with those gaps?
Add 0.
We're going to add 0. A very clever expression for 0. It's going to be two things. One positive and one negative. Now look at where we're trying to end up. What do I need to add? Look at where we're trying to end up. What needs to go up there?
Negative f of x and
Negative f of x, g of x. So what goes here? Positive f of x, g of x. Okay? So now, with that recognition, look, these guys are opposites. We just added 0 in a very clever way. They're opposites. So now, out of these two, and you see the g of x plus h, as h goes to 0, this is going to be a g of x. We're going to be fine with that. The h is going to end up going up into both parts. So I'm going to write this way. See if you can do it. This is the limit is h goes to 0 of 1 over g of x plus h times the limit is h goes to 0. I have f of x plus h, g of x, minus f of x, g of x over h. I need to have a minus sign somehow. And I'm going to establish this limit again. Now, once again, I haven't proved all the limit theorems, that the limit of a product is the product of the limits. The limit of the sum is the sum of the limits. The limit of the quotient limits. That stuff you do with delta epsilon proofs and analysis. Incredibly challenging college level, probably junior level math course. Okay, limit as h goes to 0. I took a minus, so I'm writing this as f of x, g of x plus h. I pulled a minus out of this, so it's minus f of x, g of x. This needs to be over h as well. And I'm claiming those are the same. Are there any issues with that? Now, what happens to this limit is x of x plus h, g of x plus h. As h goes to 0, this is g of x. So it ends up being my g of x quantity squared, right? So this is turning into that. Now, h is going to the 0. The g of x can be pulled right out. So let's just realize that this is 1 over g of x, the quantity squared, times, I can pull my, well, I can,
That would cancel out one of the g of x.
I pull the g of x out. There's no h in there. It's g of x times the limit is h goes to 0 of x plus h minus f of x over h, minus, what do I pull out of this? The f of x, and we're left with the limit is h goes to 0 of g of x plus h minus g of x over h. And that's it. Because this equals g of x, f prime of x, minus f of x, g prime of x, over g of x, the quantity squared. Always memorize the bottom, drew the top, minus top, drew the bottom, over bottom squared. But many students like the low d high minus high d low over low low. It's got a nice ring to it. And this is a tough little formula that we just showed was true. The derivative of a quotient is not derivative top over derivative bottom. Derivatives do not work like limits do. The derivatives are a combination, it's a special limit of a combination of functions. So it just doesn't work the same. Okay, you can cut that video.